Okay, so in notes 1, 2, we're going to be finding the equations of the inverse. Remember we talked about inverses on 1, 1. To find the inverse graph, all we did was we switched the x and y, and then we graphed the inverse. Okay, so to find the equation of the inverse, you're going to switch the x and y in the equation, and then you're going to solve for y. Okay, so number 1, we're writing the equation for the inverse of each of the following relations. Okay, so we're going to switch x and y. So instead of writing a y, I'm putting an x. Instead of putting an x, I'm putting a y. And then I'm solving for y. So I'm going to subtract 8. So that would be x minus 8 equals 4y. And then I'm dividing everything by 4. So we have y equals, I'm going to put a 1 in front of x, so that's going to be a 1/4 x. And then divide 8 by 4, so you get minus 2 there. Okay? There is an inverse symbol. Anytime you have y to the negative 1 or f of x to the negative 1, that means that's the inverse of your original y equals. So there's my inverse equation. Okay, looking at example 2, this time we have function notation. We have f of x equals 7 minus 5x. I'm going to rewrite this as y equals 7 minus 5x because those are the same exact thing, f of x and y. Okay, so I'm going to switch x and y. And then I'm solving for y. So I'm going to subtract 7. So I have x minus 7 equals a negative 5y, and then you're dividing everything by negative 5. So we have y equals, put a 1 in front of that x, so that would be negative 1/5 x, and then a negative divided by negative becomes a positive, so that'll be plus 7/5, and I'll just leave that as a fraction. Notice that our original here was f of x equals, so whenever you're writing the inverse of this, you're going to put f to the negative 1 of x, and then you can write your equation, negative 1/5 x plus 7/5. So always look back at your original. If it was an f of x function notation, then make sure you put f of negative 1 of x, and then if it was a y, then make sure you put y to the inverse. Okay. Alright, so notice number 1 and number 2, both of those were linear because we just had an x. Notice on this one we have an x squared, so we have a quadratic this time. We still are finding the inverse the same way though. So I'm going to switch x and y. Make sure that you are just replacing x and y and you're not taking the squared with that x. So all you're doing, everywhere you see a y, you're putting an x. Everywhere you see an x, you're putting a y. So do not replace that squared or carry over that squared with the x. You're just replacing those, and then you're going to solve for y. So we're going to add 6. So we have x plus 6 equals 2y squared. And then we're going to divide everything by 2. So we have y squared equals, putting a 1 in front of that, so that's 1/2 x. And then 6 divided by 2 gives us 3. Now, on the other ones we were done at that point, but notice we have a squared. We just went over how to get rid of a squared, or we talked about it. We take the square root of both sides. So whenever I do that, remember when you take the square root of both sides, you should get a positive and a negative answer. Square root of 1/2 x plus 3. Now the square root of y squared is just y. So make sure when you take that square root of both sides, when you're trying to figure out what squared gives you 1/2 x plus 3, it should be a positive and a negative. Look back at the original. We did have a y as our original, so we're going to do the inverse of y, so y to the negative 1 power. And that would be our inverse equation. Okay, so let's look at the back. Now it says write the equation of the inverse. So we're first going to write the equation of the inverse. We're going to graph y equals x as a dotted line. And then we're going to graph the following relation and its inverse in the same set of axes. Okay, so first I'm finding the equation of the inverse. So I'm going to switch x and y. And I'm going to solve for y. So subtract 4. So we have x minus 4 equals 2y. And then you're dividing everything by 2. So y equals, put a 1 in front of x. So that would be 1/2 x minus 2. This is the inverse, so put y to the negative 1, which is the inverse. Okay, so it told us after we found the equation of the inverse, graph the line y equals x. If we have the line y equals x, the slope is 1/1, the y-intercept is 0. Okay, so it crosses the y at 0, and then the equation y equals x, you're going up 1, right 1. So I'm just going to make a dotted line for that y equals x line. We talked about that yesterday, our y equals x line. Okay, so then we're going to graph. I'm going to graph my first one. Since it's linear, I'm just going to use slope and y-intercept. Slope would be 2/1. Y-intercept would be 4. So it crosses the y at 4. And then we're using the slope, so we're going to go up 2, right 1. And then we're going to connect those points. So this is y. I'll just call that, label that as y. Okay, so graphing that next one, the inverse slope would be 1/2. Y-intercept would be -2. So it crosses the y at -2. And then we're going up 1, right 2. Up 1, right 2. And continue that. The inverse of y. Okay, so it says, is the relation a function? When it refers to the relation, it's talking about your original. So we're looking at this pink one. Okay, so if we look back, is that a function? Remember, we can use the vertical line test. It should only intersect at one point. So notice if we drew a vertical line or use that vertical line test, it would only intersect at one point. So yes, the relation would be a function. Okay. Then it asks, is the inverse a function? So the inverse is the one that you found, so the blue one. So if you look at that one, that's also a straight line. If you draw a vertical line, it's only intersecting at one point. So that would also be a function. Okay, so on 5, we first want to find the inverse equation. So I'm going to rewrite this as y equals x squared plus 1 because I know f of x is the same thing as y. And once I have it in that form, I'm just going to switch x and y. Remember that square does not go along with the x when I switch it. It should just be x equals y squared. So you're replacing the x with y. So that's what's squared now, plus 1. So I'm going to subtract 1. So I end up with x minus 1 equals y squared. And then remember we talked about on the front, to get rid of that squared, we have to take the square root of both sides. So whenever you do that, you should have a positive and a negative answer that you could plug plug back in for y and square it and still get x minus 1. So it would be a positive and a negative square root of x minus 1. Since we look back at the original, it was in function notation. So the inverse would be positive and negative square root of x minus 1. Okay, so when we're graphing a quadratic one, you can remember back your vertex, what happens to the vertex as you do plus 1, it goes up 1. You can also use the calculator. So you could plug in your original, x squared. Oh, go to y equals x squared plus 1. So if you look at your table there, okay, so negative 2, 5, negative 1, 2, 0, 1, 1, 2, and 2, 5. Also the 3, 10, negative 3, 10. Okay, there's my relation, which is my original f of x. I'm going to draw my y equals x line. And then now I'm going to, two different ways of doing this. We know from learning from yesterday, we could just take those points that we just found in the table and switch those to find the other one. So I could just write down those points that I just found. So negative 3, 10, negative 2, 5, negative 1, 2, 0, 1, 1, 2, 2, 5, and 3, 10. That was my relation, my original one. So you could take that and then just flip the x and y, and that would be your inverse graph. Or you could also type in that inverse, so you could do the square root of x minus 1. But then you also have a negative square root of x minus 1, because if you look at your inverse there, it's positive and negative. So you have to put negative square root of x minus 1. So two different ways of doing it. Either take your original points and just flip them, or do this and then only find the ones that you're able to plot. So you should be able to go through. I think it's easier just to look at this table that you have written down for your relation and then just flip those x and y's. But you can do either one. Okay, so if I flip this one, now it's going to be 10, negative 3, 5, negative 2, 2, negative 1, 1, 0, 2, 1, 5, 2, and 10, 3. So this way, when we do the inverse of this, it's a sideways parabola. So that was your inverse. Okay? So you can either use your table of your relation to flip it and find the inverse, or plug this in, positive and negative, into the calculator and look at the table. Alright, so is the relation, which is our original, is the relation a function? Okay, so if you look back at this pink one, if you were to use a vertical line test, it only intersects at one point. So that would be a function. Is the inverse a function? If you look back at the blue one, if we were to draw vertical lines, notice that it would intersect at two different points. Therefore, those x's repeat, and it's not a function. So the inverse would not be a function there.